Hello students, this is Indrani ma'am from Rasayan. In this lecture, I am going to explain some more important questions on general organic chemistry. Question number 1. Identify most acidic hydrogen in the given compound. One compound is given. Now, see this hydrogen means here this is carboxylic acid. So, this hydrogen, this is alcoholic OH, this hydrogen here at alpha position of CO, keto group, this hydrogen, and here thiol is there, this hydrogen. Out of this 4 hydrogen, which is most acidic? To check the acidity, here what you have to do? First you have to remove the H plus from this position to form the corresponding conjugate base. Now see, removal of H plus from this carboxylic acid will give this carboxylate ion. Removal of H plus from alpha position of keto group will give this anion. Removal of H plus from here will give this anion, and removal of H plus from here will give this anion. So you have to see which anion is more stable. Now see, this anion is stabilized by resonance because at conjugate position CO group is there. This is carboxylate ion. So here what we are having, equivalent resonating structures are there. So this is another resonating structure of carboxylate ion. And these anions are not getting conjugative stability. So out of this 4 anion, this is most stable due to resonance because it is having equivalent resonating structure. Therefore, these are most stable anion. So, corresponding acid is most acidic. Therefore, which hydrogen is most acidic? This hydrogen A is most acidic here. Next question. Which of the following compound would you expect to be stronger carbon acid? 4 compounds are given. Always remember, the more stable the conjugate base is, the more acidic is the parent acid. That means, if conjugate base is most stable, its parent compound is most acidic. So what we have to do? We have to compare the stability of the corresponding conjugate bases of these compounds. So one by one we will see. Now see, this is bicyclic compound, and if you consider this carbon, here this carbon is bonded to 3 more carbons. So here one hydrogen is there. So if you want to draw the structure of conjugate base of this compound, what you have to do? You have to remove this H plus. What we are doing? We are removing H plus. So what we are getting? This carbon ion we are getting. Now see here, at adjacent position here, CO group is there. That means negative charge and CO, these are at conjugation. So if resonance takes place, what you will get here? Double bond at the bridgehead position. It's very unstable. Double bond at the bridgehead position is very unstable. So this type of resonance is not possible. So only this negative charge will get stability due to minus I effect of these CO groups. Okay. Here also same thing. Here after removal of H plus we will get the carbon ion which is not stabilized by resonance. Only to some extent it will be stable due to minus I effect of CO group. So what we have seen, actually carbon ion of this and these compounds are unstable because these are not getting resonance stability. But what is about this compound and this compound? Now see, this is diethyl malonate. After removal of this H plus, we are getting this carbon ion. and this carbon ion is resonance stabilized from both the side. What will happen? This will go and it will involve in resonance. But here resonance is less effective. Why resonance is less effective here? Because see here at both the side adjacent to this carbon ion COOET group is there. Now if you break this, then oxygen lone pair is in conjugation with this double bond. So this lone pair will be involved in resonance. So here this carbon ion will be less resonance stabilized because OET, that oxygen is supplying electron here. So here resonance is less effective involving this carbon ion. But what is about this compound? This is the conjugate base of this beta keto ester. With respect to this ester, this carbon is alpha, this is beta. This is beta keto ester. So if you remove H plus from here, we are getting this conjugate base. And if you clip this bond, then this lone pair will be involved in resonance. But here if you clip this bond, here CH3 group is there. So that resonance is not possible. So it will be involving in resonance with this. So here resonance is more effective than this. And due to resonance, this carbon ion is more stable. Since it is more stable, therefore corresponding compound is most acidic. Therefore this is your answer. Next question. 5-bromo-2-cyclopropyl cyclohex-2-enol have correct structure. 4 structures are given. Now see, in this compound you can see 2 substituents are there. One is this cyclopropyl, another is bromo. And 2 functional groups are there, OH and alkene. And you know priority of OH is more than alkene. So what we have to do, from this OH we have to start numbering. Then next functional group is alkene. So it should get next number. Then 3, then 4, then 5, then 6. Now see, first we have to write the name of the substituent. So 5-bromo, at 2 position cyclopropyl group is there. Main ring is having 6 carbon atom and it is cyclic. So cyclohex. At 2 position double bond is there. So 2 in and 1 position all is there. So 2 in 1 all or 2 in all, and since it is starting with vowel, so this E you have to drop. So we are getting 2 in all. We are getting here 2 in all. So this is the correct structure. Since these OH and these double bonds are functional group, so at the end we are writing its name. So these are coming as suffix. Hope it's clear to you. If you like, please subscribe. Thank you for watching.